Okay, so here's a common question that really tends to bug students quite a bit. Let's start with a single assumption, okay? Let's start with one single assumption. Here's the assumption. Assume y is equal to beta 0 plus beta 1 times x plus epsilon. Or if I wanted to just give you the assumption of per every single data point, I could have said every single data point will be generated by this. Okay? And let me make one further assumption in the same thing here. Let me assume that the expected value of epsilon I is equal to 0. Okay? We're going to take this assumption here and we're going to try and explain this idea of a true line, a fitted line, data points, fitted values, error term, and residuals that tend to confuse students quite a bit. Okay? So, this is the only thing that I assume. So what can I say about what is the expectation of y going to equal to? What is the expectation of y going to equal to under this assumption? Well, it's going to be equal to the expectation of beta 0 plus beta 1 x plus epsilon. Agree? But what would this equal to? Well, beta 0 is an unknown constant. Beta 1 is a constant. X will be known because I'll have the x variable plus the expected value of the epsilon. But what do I know by this assumption? That must be equal to 0. So this thing here is equal to 0 by assumption. Not always, but just by the way we've assumed stuff. Okay. So I could visualize this. I will never have this in my data, but I could visualize it. I could say if I have x here and y here, I could visualize the expected value of y as being something like this, which I'm going to call the true line. I'm going to say, well, it's going to have an intercept of beta 0. It's going to have a slope of beta 1. And this I call the true line. True line. Note, I cannot think or talk or envision a true line unless I know or I assume that this top bit here is correct. If that top bit there is not correct, there is no point in talking about a true line. Right? But that's the baseline that I need. I need that assumption, okay? Now, that's the concept of a true line. That's what a true line is. Now let's look at data points. Well, let's take a few data points. Let's say that your first data point was here, your second data point was here, and then your third data point was here. Okay? If those were the data points, and assuming that you know that that is the true line, what can you say? What are the error terms associated with it? Well, I go back to this model. The model says that every single data point, I should be explaining this by the true line plus some error term. Okay? So this bit here is epsilon 1. This bit here is epsilon 2. This bit here is epsilon 3. Okay? Those are the true residuals. This point here is simply a data point. Data point. And that particular data point will have an actual y value like y1. Okay? This particular data point here will also have a y and an x variable like y3, for example. That's 1, 2, 3. Okay? What's going to be the fitted line? The fitted line is going to aim at, it's going to be the OLS line, right? And it's going to probably look something like this. This is the y hat, which is equal to the beta 0 hat plus beta 1 hat times x. That's the fitted line. That's my prediction. That's my predicted y's, okay? So for this particular value of x, my fitted one seems to be fairly close to it, right? This is going to be my y1 hat. Okay, that's the fitted value. What do you know about the sum of the fitted residuals? So what are the fitted residuals? Are the difference between the green line, the fitted line, and the actual data points. So this bit here is my epsilon 3 hat. This bit here is my epsilon 2 hat. This bit here, epsilon 1 hat. What do I know about the sum of all of those? Should be equal to 0 by mechanical property. If they're not, I haven't fit the OLS line correctly. Okay, so that's the true line. The fitted line is the green line. The residuals are the difference between the data points and the fitted line, which I can calculate. The fitted values are this y hat that I find here, y1 hat. What about for x? Well, for this bit, I go on the red line. For the second data point, this is the fitted value for y. Okay? This thing I can observe. The error term I cannot observe. The residual I can calculate. What are the unobservable stuff? The true line is unobservable. The error terms are unobservable. Everything else can be calculated from the data or is observed from the data. Make sure that you understand those distinctions. Okay? We'll stop here.